Yesterday, we were introduced to the concept of the mole, a unit of measure in chemistry that we use to deal with very large numbers, such as numbers of atoms or numbers of molecules. Yesterday, we practiced using mole relationships to calculate grams of an element using the relationship between atomic mass found on the periodic table and 1 mole, and also the idea that 6.022 times 10 to the 23rd atoms or molecules or units of anything is equal to 1 mole of that substance. And this is pretty useful, but actually in chemistry we do more than just study individual elements. We also like to study compounds and additionally how different elements and compounds react with each other. So what we'd like to be able to do is use the mole to talk about and calculate things for compounds in addition to calculating different quantities for just elements. So we'll be talking about something called molar mass and also the mole volume relationship. Molar mass is defined as the mass in grams of 1 mole of a compound. So if you have a molecule and you want to know its molar mass, that's going to be how much does 1 mole of that compound, so 1 mole of sugar, 1 mole of salt, 1 mole of chalk, which is calcium carbonate, how much does 1 mole of this substance weigh? And we can easily calculate this using our best friend, the periodic table. So if we take one molecule for an example, we can try to calculate the mass of 1 mole of glucose. The formula for glucose is C6H12O6, and this molecule is the compound that we commonly think of as sugar. So if I want to know the mass for 1 mole of glucose, I can consider the mass for 1 mole of each of its parts. We can consider first the mass of carbon, the first element in the compound. And so we could use the atomic mass of carbon and the fact that it occurs 6 times to calculate the mass contribution of carbon. We could do the same thing for hydrogen and also for oxygen, and that looks like this. If we want to know the mass of 6 carbon atoms that are in the glucose compound, we can do 6, the number of times carbon is in the compound, multiplied by the atomic mass of carbon, which is going to give us the contribution of carbon in this compound. Next, I could look at oxygen. I have 6 oxygens contributing to this compound. Each oxygen has an atomic mass of 16 grams per mole, which means that the contribution of oxygen is 96 grams per mole in glucose. The last element to look at is hydrogen. We have 12 hydrogens. Each one has a 1.01 gram per mole atomic mass, which means that its contribution is 12.12 grams per mole. Now, if I want to know the molar mass of the whole compound, all I need to do is add up the mass of each of the parts. So I have 72.06 plus 96 grams per mole plus 12.12 grams per mole, which gives me 118 grams per mole as the molar mass of glucose. This means that in 1 mole of glucose you have 180.18 grams of substance. This is a very useful number for us because just like we could use atomic mass to go from grams to moles of an element, we can use molar mass to go from grams to moles of a compound. And that's what we're going to do next. Using molar mass. We can use molar mass to go from moles of a compound to grams of a compound, or from grams of a compound back to moles of a compound. Let's do 2 examples. The first example says how many moles of C2H6 are in 105.28 grams of C2H6. When I look at this problem, I recognize that it's dimensional analysis because I'm starting with grams and I want to find moles. So I'm changing my units. Moles is my target. 105.28 grams is my starting point. Now, it's obvious here that we are missing a conversion factor. And so I'm going to think about what kind of conversion factor I need here. I need something that's going to let me go from grams to moles of a compound. So what I actually need is the molar mass of C2H6. So I need the molar mass of C2H6. Let me rewrite that so that it's on the screen and we can see it. Conversion factor will be the molar mass, C2H6. Okay, so we need to find the molar mass of C2H6. That's going to be our first step to solve this problem. So if we want to find the molar mass of C2H6, we'll consider the atomic mass of each of its parts and then find the total. So we know that there are 2 carbons in C2H6. So we're going to do 2 multiplied by the atomic mass of carbon, which is found on the periodic table at 12.01 grams per mole. Then I'm going to add to that the hydrogen contribution, which is that there are 6 hydrogens at 1.01 grams per mole. I'm going to multiply 2 times 12, and I'm going to multiply 6 times 1.01, and I'm going to total those up, which gives me 30.08 grams per mole as the molar mass of C2H6. So we can now write that as our conversion factor. We could say that 1 mole of C2H6 equals 30.08 grams of C2H6. Now that we have our conversion factor, our target, and our starting point, we're ready to solve this problem. We'll begin with our starting point, 105.28 grams of C2H6. We know over here that our target is to have moles of C2H6. I'm going to use my conversion factor, and I'm going to identify that I need grams of C2H6 on the bottom and moles of C2H6 on the top. So on the bottom, my grams are 30.08 grams of C2H6, and I know that that's in 1 mole of C2H6 because that's my conversion factor that I calculated earlier. Now I can solve my dimensional analysis problem by checking my units. My grams cancel. My target is moles. That checks out. I'm going to divide the top by the bottom. So 105.28 divided by 30.08, and that gives me 3.5 moles of C2H6. The next problem is simply going the other direction. We want to take the mass of 1.68 moles of iron, 3-chloride, and go back and find the grams of that. So we can begin by making sure we know the formula for the compound. We have iron 3. Iron is Fe, and it has a charge of positive 3. Chlorine is Cl. Chlorine is a halogen with a charge of -1. And so we know that we're going to need 3 chlorides in order for that to be a balanced neutral compound. So the formula for iron 3 chloride is FeCl3. Now we can start thinking about trying to solve this problem. We have a target, which is mass, and we have a starting point, which is 1.68 moles. And so again, we need to find our conversion factor. We will total all of the components of iron 3 chloride to find the molar mass of iron 3 chloride. So we have 1 iron. The atomic mass of iron is 55.845 grams per mole. We add that to the 3 chlorines, which each have a mass of 35.45 grams per mole. If I multiply and add to solve for the molar mass, I get 162.195 grams per mole FeCl3. All right, so now we have our conversion factor, our molar mass. We're ready to solve this problem because we have our target and our starting point as well. If I begin with my starting point, 1.68 moles of iron 3 chloride, I know that my target is going to be the mass in grams of iron 3 chloride. I need moles on the bottom to cancel out, and I need grams on the top to match my target. My conversion factor shows me that for 1 mole of iron chloride, I should have 162.195 grams. If I check on my units, my moles cancel. I'm left with grams. That checks out. And then I have just simply to solve the problem. So I'm going to multiply the top together. I'm going to divide by the bottom, which is just 1. And this gives me 272.49 grams of iron 3 chloride in 1.68 moles of iron 3 chloride.